There's something almost hypnotic about staring into the depths of space, isn't there? The sheer vastness, the endless sea of stars, each one hiding secrets we've barely begun to uncover. And then there are places like the Coma Cluster, a cosmic enigma so puzzling it keeps astronomers awake at night. Nestled about 320 million light-years away in the constellation Coma Berenices, this massive gathering of galaxies isn't just another dot in the sky. It's a swirling, dynamic mystery, packed with phenomena that defy everything we thought we knew about how the universe works. Picture this, a region of space where galaxies huddle together by the thousands, bound by gravity in a dance that's lasted billions of years. But here's the twist, something unseen is pulling the strings. Strange forces at play, dark matter lurking in the shadows, and energies so intense they warp the very fabric of reality. The Coma Cluster isn't just a scientific curiosity, it's a cosmic crime scene filled with clues that could rewrite our understanding of physics itself. And yet, despite decades of study, the more we learn, the more questions pile up. That's what makes this journey so thrilling, because today we're diving deep into the heart of the Coma Cluster, uncovering 25 of its most bewildering mysteries. From ghostly radio emissions with no clear source to galaxies that move in ways they absolutely shouldn't, each discovery pulls us deeper into the unknown. And by the end of this, you'll see why scientists call this place one of the greatest puzzles in modern astronomy. So buckle up, we're about to explore a corner of the universe where the rules as we know them don't always apply, and where every answer only leads to another, even more fascinating question. One of the most baffling riddles the Coma Cluster has thrown at scientists involves something that isn't there. We've long known that dark matter, that invisible, mysterious substance making up most of the universe's mass, should be everywhere, especially in massive galaxy clusters. But in certain corners of the Coma Cluster, it's just gone. Galaxies like NGC 4889 and others nearby move as if they're floating in empty space, with almost none of the gravitational pull we'd expect from dark matter. It's like watching a dancer twirl without music. Their motions make no sense without the unseen force guiding them. This discovery sent shockwaves through the astrophysics community because it upends our fundamental understanding of how galaxies form. According to current models, dark matter acts as the cosmic scaffolding, pulling gas and stars together to build galaxies. Without it, these galaxies shouldn't exist at all, or at the very least, they should be flying apart. So what's happening? One leading theory suggests brutal galactic collisions might have ripped the dark matter away. The Coma Cluster is a chaotic place with galaxies constantly smashing into one another. If two galaxies clash just right, the dark matter could have been flung out into the void, leaving the stars behind like debris after a storm. But there's another, even wilder possibility. What if dark matter isn't missing but hiding? Some researchers propose that certain exotic particles could interact in ways we've never detected, making the dark matter effectively invisible even to our most sensitive instruments. Or perhaps our models are simply wrong, and dark matter behaves differently in extreme environments like the heart of a galaxy cluster. Every telescope pointed at these oddball galaxies brings us closer to an answer, but for now, the mystery only deepens. One thing's certain, solving this puzzle won't just explain the Coma Cluster's quirks. It could force us to rewrite the rules of the cosmos itself. Among the Coma Cluster's many cosmic oddities, few are as hauntingly beautiful or as baffling as the ultra-diffuse galaxies. Imagine a galaxy so faint it barely outshines the blackness of space, yet spread so wide it rivals the Milky Way in size. These ghostly giants drift through the cluster like cosmic phantoms, their stars so thinly scattered you could fly through one for light years without noticing. And yet, the Coma Cluster is absolutely teeming with them. What makes these galaxies so perplexing isn't just their eerie appearance, it's the fact they exist at all. By all rights, they should have been torn apart long ago. The Coma Cluster is a gravitational battlefield with titanic forces ripping ordinary galaxies to shreds. Yet these ultra-diffuse galaxies not only survive, they thrive. Some, like Dragonfly 44, are practically invisible, emitting just 1% of the light of our Milky Way. But when astronomers finally managed to measure their mass, they got a shock. These faint wisps contain nearly as much dark matter as our own galaxy. It's like finding a feather that somehow weighs as much as a boulder. So how did they form? One theory suggests they were once normal galaxies, stripped bare by the cluster's ferocious tides, leaving behind only their dark matter skeletons. Others propose they were born this way, anemic from the start, their stars sputtering out in the cosmic equivalent of a failed firework. But here's where it gets even stranger. Some ultra-diffuse galaxies in the Coma Cluster show almost no dark matter at all, flipping the script entirely. It's as if the universe decided to throw out the rulebook and experiment. The real kicker, these galaxies might hold clues to one of astronomy's biggest unsolved problems, the nature of dark matter itself. If they formed without it, our entire understanding of galaxy formation could need a rewrite. And if they're dark matter rich, their survival in the cluster's chaos might reveal how this mysterious substance behaves under extreme conditions. Either way, these faint, sprawling enigmas are forcing us to question everything we thought we knew about the building blocks of the cosmos. If the Coma Cluster's missing dark matter left scientists scratching their heads, its radio halo has them utterly bewildered. Stretching over millions of light years, this colossal cloud of radio waves envelops the entire cluster like a ghostly shroud. It's not tied to any single galaxy or visible structure, just an immense invisible globe buzzing with energy, and the sheer scale of it defies easy explanation. What's fueling this cosmic static? The leading theory points to chaos at the cluster's core. The Coma Cluster isn't just a quiet gathering of galaxies, it's a gravitational mosh pit. Galaxies slam together at dizzying speeds, sending shockwaves rippling through the superheated gas between them. These collisions might be accelerating particles to near light speeds, turning the entire region into a natural particle accelerator. When those high-energy particles spiral along magnetic fields, they emit the radio waves we detect. It's like the universe's version of a neon sign, flickering with energy but powered by violence. Yet even this explanation has gaps. For one, the halo's energy distribution is uneven, with some areas inexplicably brighter than others. Then there's the fact that not all galaxy clusters have radio halos, even turbulent ones. Why does the Coma Cluster produce such an intense signal? Some researchers suspect an invisible player, perhaps dark matter particles annihilating each other, releasing energy in the process. Others propose that the cluster's unique history, like a past merger with another massive cluster, left behind this energetic echo. But here's the twist: the radio halo might be more than just a curiosity. It could be a cosmic feedback loop. The same shocks that create the radio waves might also heat the cluster's gas, preventing it from cooling and forming new stars. In other words, this invisible phenomenon could be silently shaping the fate of thousands of galaxies. And that's what makes the Coma Cluster's radio halo so fascinating. It's not just a mystery to solve. It's a window into the forces that sculpt the universe on the grandest scales. Some galaxies in the Coma Cluster seem to have forgotten how to make stars, while others are cranking them out like cosmic factories, and nobody quite knows why. Take the massive elliptical galaxies near the cluster's core. These ancient giants are practically stellar graveyards, with star formation rates so low they're almost dormant. Meanwhile, on the cluster's outskirts, spiral galaxies are bursting with newborn stars, glowing with young, blue-hot energy. This bizarre divide isn't just random, it's a cosmic clue, pointing to the brutal environment these galaxies call home. The culprit, the Coma Cluster's own atmosphere, literally. The space between galaxies here isn't empty, It's filled with superheated gas, a plasma so scorching it could vaporize entire solar systems. For galaxies venturing too close to the cluster's center, this gas acts like a sandblaster, stripping away their cool hydrogen fuel, the very ingredient needed to form new stars. Astronomers call this process ram pressure stripping, and it leaves galaxies starved and sterile, their star-making potential snuffed out. Picture a candle flame being smothered by a hurricane. But there's a twist. Some galaxies aren't just passively losing their gas, they're having it torn away by gravitational bullies. The Coma Cluster's immense gravity creates tidal forces so strong they can yank entire arms off spiral galaxies, disrupting their delicate balance. Others get caught in violent mergers, where collisions trigger chaotic bursts of star formation before leaving the galaxies exhausted. It's like watching a frenzied fireworks display that burns out too quickly. Yet, even in this hostile environment, rebels thrive. Certain galaxies, particularly those rich in dense molecular gas, manage to shield their star-forming regions from the chaos. Others might be newcomers falling into the cluster for the first time, their gas reservoirs still intact. And then there are the rare oddballs where star formation ignites in unexpected places, like near supermassive black holes, where jets of energy paradoxically compress gas into stellar nurseries. What makes this puzzle so crucial is what it reveals about galaxy evolution everywhere. The Coma Cluster is a time lapse of cosmic forces at work, showing us how environments shape destinies. If we can decode why some galaxies here fade while others flare, we might finally understand why our own Milky Way looks the way it does, and what its future holds in a universe where even starlight isn't guaranteed to last. The Coma Cluster doesn't just host a few dwarf galaxies, it's absolutely crawling with them, far more than astronomers ever expected. These tiny cosmic specks, some no bigger than 1,000th the mass of the Milky Way, should be rare. Yet here they are, clumped together in shocking numbers like fireflies swarming a summer night. And that overabundance isn't just a curiosity, it's a direct challenge to everything we thought we knew about how galaxies form. So why is the Coma Cluster drowning in dwarfs? One clue lies in their dark matter halos, those invisible cocoons of mysterious mass that surround galaxies. According to theory, dark matter's gravitational pull should act like a cosmic seed, gathering gas and dust to birth stars and galaxies. In most places, that process creates a predictable mix of galaxy sizes. But the Coma Cluster's extreme environment might be warping the rules. Some researchers think its intense gravity could be stretching smaller galaxies, breaking them into dwarf-sized fragments while leaving their dark matter halos intact. It's like throwing a handful of clay into a whirlpool. What started as a few lumps gets torn into countless tiny pieces. Then there's the tidal force theory. The Coma Cluster is a gravitational meat grinder, with galaxies constantly yanking at each other. As larger galaxies pass by, their gravity can rip streams of stars and gas from smaller neighbors, leaving behind dwarf galaxies like cosmic crumbs. This might explain why so many dwarfs here are ultra-faint, barely held together by their own gravity. Others could be remnants of ancient collisions, galactic debris left orbiting the cluster like bees around a hive. But the plot thickens. Some of these dwarfs are huddled in eerily neat lines, as if strung along invisible threads. This has led to a wilder idea. What if they're not victims of destruction, but artifacts of creation? The cluster's dark matter might be arranged in vast, web-like filaments, with dwarf galaxies forming like beads on a string wherever these invisible roads intersect. If true, these tiny galaxies could be tracing the hidden skeleton of the universe itself. The implications are staggering. If the Coma Cluster's dwarf galaxies are teaching us how dark matter shapes cosmic structures, they might hold the key to understanding galaxy formation everywhere. Or perhaps they're evidence of something even stranger, like undiscovered physics governing how matter clumps together in extreme environments. Either way, these minuscule galaxies are proving that sometimes the smallest things can reveal the universe's biggest secrets. Wander through the Coma Cluster with an astronomer's eyes, and one color dominates the cosmic landscape: red. Not the fiery red of newborn stars, but the dull crimson of aging suns, a phenomenon so widespread it's earned its own name, the red sequence. This isn't just a quirk of aesthetics, it's a glaring clue that something in this cluster has pressed pause on star formation for billions of years. And the deeper we probe, the more this red dominance defies expectations. Galaxies elsewhere in the universe come in all stages of life: blue spirals sparking with youthful stars, irregulars splashed with pink stellar nurseries. But the Coma Cluster's core is a retirement home for galaxies, where vibrant star-making has ground to a halt. The question isn't just why these galaxies are red, but why so many turned red so early. Current models predict galaxies should transition slowly as their gas runs out, yet here, entire populations seem to have aged in unison, like a forest where every tree shed its leaves on the same day. The prime suspect, the cluster's own extreme environment. Between galaxies, superheated plasma reaching millions of degrees acts like a cosmic blowtorch, evaporating the cool hydrogen gas needed to birth stars. But that's just part of the story. Observations reveal something stranger. Many red sequence galaxies still have gas reservoirs, yet they're not forming stars. It's as if someone flipped a master switch, shutting down star production galaxy-wide. Some theorists point to the cluster's ferocious gravitational tides, which might compress gas just enough to prevent it from cooling into dense, star-forming clouds. Others suggest relentless harassment from passing galaxies disrupts delicate molecular structures before stars can ignite. Then there's the dark matter angle. The Coma Cluster's immense halo of invisible mass might be generating tides powerful enough to strip gas not just from galaxies, but from the very space between them, starving entire neighborhoods of star fuel. Or perhaps the red sequence is a relic of ancient cosmic violence, mergers so colossal they triggered brief, explosive star formation that burned through gas reserves in a frenzy, leaving galaxies permanently exhausted. What makes this mystery so pivotal is its implications beyond the cluster. If environmental forces can shut down star formation this efficiently, it could explain similar red sequences in other dense regions of the universe. Even our Milky Way may one day join this crimson parade when it collides with Andromeda. The Coma Cluster's red galaxies aren't just aging gracefully, they're holding up a mirror to the fate of galaxies everywhere, showing us a future where star formation isn't just rare but impossible. And that's what transforms this sea of red from a curiosity into a cosmic warning sign. Between the galaxies of the Coma Cluster, if you look carefully enough, you'll notice something strange, a faint, ghostly glow. It's not coming from any one galaxy, but from billions of stars drifting untethered in the darkness. Astronomers call this eerie radiance intracluster light, and it's one of the most haunting features of the Coma Cluster. These aren't just any stars, they're cosmic orphans, ripped from their home galaxies and left to wander the void alone. What's even stranger, this glow isn't spread evenly. Some regions of the cluster shimmer with it, while others remain almost pitch black, and that unevenness holds a violent history. The leading theory for how these stars got there reads like a galactic horror story. The Coma Cluster is a gravitational war zone where galaxies constantly tug, collide, and tear each other apart. When two galaxies pass too close, their mutual gravity can pluck stars from their outer edges, flinging them into the abyss. In more violent encounters, entire galaxies merge, their structures shredded in the chaos, leaving behind streams of stars like cosmic breadcrumbs. Over billions of years, these scattered stars accumulate, creating the diffuse glow we see today. Yet the distribution of this light is anything but random. Some of the brightest patches trace the paths of ancient collisions, marking where especially brutal mergers took place. Others cluster around the largest galaxies, as if the gravitational giants are hoarding the stellar refugees. And then there are the void's regions where the light nearly vanishes, suggesting even the orphaned stars avoid these cosmic dead zones. This patchiness is a puzzle because if the stars were scattered evenly by random interactions, the glow should be uniform. Instead, it's a cosmic fingerprint, revealing the cluster's most violent moments frozen in starlight. What's even more intriguing is what these stars can tell us about dark matter. The way they're distributed doesn't quite match the visible mass of the cluster, but it does align eerily well with maps of its dark matter. Some researchers think these wandering stars might be tracing the invisible scaffolding of the universe, their movements betraying the hidden pull of dark matter's gravity. Others speculate that certain regions lack intracluster light because dark matter's grip there is too weak to hold onto the stars, letting them drift away entirely. Then there's the twist: some of these stars might not be orphans at all, but pioneers. A controversial idea suggests that a fraction of the intracluster light comes from stars born right in the void, in pockets of gas too sparse to form galaxies but dense enough to spark a few solitary suns. If true, it would mean star formation can happen in places we never thought possible, rewriting the rules of where and how stars are born. Regardless of their origin, these lost stars are more than just a celestial spectacle. They're a record of the Coma Cluster's turbulent past, a way to reconstruct collisions that happened billions of years before Earth even existed. And as telescopes grow more sensitive, this faint glow could reveal secrets not just about the cluster's history, but about the nature of dark matter itself. In the end, the universe's loneliest stars might hold the key to some of its biggest mysteries. Some galaxies in the Coma Cluster aren't just moving, they're racing, hurtling through space at speeds that leave astronomers utterly stunned. We're talking velocities so extreme they shouldn't be possible, like cosmic dragsters blasting through an interstellar speed trap. Take galaxy NGC 4874, for example, clocked at nearly 3,000 kilometers per second, fast enough to cross the entire United States in less than a second. At that pace, you'd expect these galaxies to fling themselves straight out of the cluster. Yet somehow they're still here, bound by gravity in defiance of every expectation. So what's propelling them? The immediate suspect is the cluster's immense gravity, fueled by its staggering mass. But here's the catch: even when we account for all the visible matter, the galaxies, the hot gas between them, the math still doesn't add up. These speed demons are moving too fast for the cluster's known mass to hold onto them. That discrepancy points to something invisible at work, and dark matter is the prime candidate. The prevailing theory suggests the Coma Cluster is wrapped in an enormous halo of this mysterious substance, its gravitational grip far stronger than anything visible matter could provide. Imagine a whirlpool with an unseen current dragging everything inward. That's the kind of force we're dealing with. But the plot thickens when we look at where these speedy galaxies are located. Many aren't just randomly scattered, they're clustered along specific trajectories like cosmic highways. Some researchers think these paths might trace filaments of dark matter, invisible rivers of mass winding through the cluster, accelerating galaxies along their currents. Others propose even wilder ideas, like hidden black holes or exotic particles interacting in ways we haven't yet detected. There's even a fringe hypothesis that the cluster's core might harbor a supermassive black hole so colossal it's warping the motions of entire galaxies, though no such object has ever been observed. What makes this mystery so critical is what it reveals about gravity itself. If dark matter's grip is truly responsible for these extreme speeds, the Coma Cluster's fastest galaxies could be giving us a rare glimpse into how this enigmatic substance behaves on colossal scales. But if another force is at play, something beyond our current understanding of physics, then these galactic sprinters might be the first hint of a cosmic rulebook we've yet to crack. Either way, their breakneck journeys are rewriting what we thought we knew about the forces that shape the universe. Amid the sea of aging red galaxies in the Coma Cluster, there's a splash of color so unexpected it looks like a cosmic mistake, a brilliant, swirling patch of blue. Astronomers call it the blue blob, a region of furious star formation burning with the intensity of 1,000 suns. It shouldn't be here, not in the heart of a cluster where star-making is supposed to be dead. Yet this vibrant anomaly defies the rules, churning out new stars at a rate that rivals the most active galaxies in the universe. The mystery deepens when you realize the blue blob isn't centered on any one galaxy. It's floating between them, a stellar nursery untethered from the usual cosmic anchors. So where did it come from? One theory points to a catastrophic collision. The Coma Cluster is a demolition derby of galaxies, and when two gas-rich spirals smash together, the resulting shockwaves can compress vast clouds of hydrogen, igniting a firestorm of star birth. It's like striking a match in a room filled with gas. Suddenly, everything lights up at once. But there's a twist. The blue blob stars are unusually young, suggesting this frenzy started relatively recently. That's led some researchers to propose an even wilder idea. What if the blob isn't the aftermath of a crash, but the result of a cosmic heist? The cluster's immense gravity could be stripping gas from smaller, passing galaxies, funneling it into a concentrated region where it collapses under its own weight. Imagine a celestial thief gathering interstellar loot and dumping it all in one place, creating a bonfire of star formation. Then there's the dark horse theory. The blue blob might be feeding on an invisible reservoir. Some simulations suggest the Coma Cluster is crisscrossed by filaments of cold gas, remnants from the early universe. If the blob stumbled into one of these primordial rivers, it could be guzzling fuel we can't even see. That would explain its isolation. It's not tied to galaxies because it's drawing from something far more ancient. What makes this blue enigma so fascinating isn't just its defiance of expectations. It's a living lab for how stars can form in the most hostile environments. Most theories assume star birth requires the stable cradle of a galaxy, but the blue blob proves nature can cook up new suns in the most chaotic kitchens. And if gas can accumulate and ignite in the void between galaxies, it upends our understanding of where and how stellar life begins. The clock is already ticking on this cosmic oddity. Without a galaxy's gravity to hold it together, the blue blob stars will eventually drift apart, scattering into the cluster like embers from a dying fire. But for now, it's a blazing testament to the universe's relentless creativity, a reminder that even in the most forbidding corners of space, the spark of creation finds a way. Even in a universe filled with mysteries, the Coma Cluster presents us with something peculiarly unsettling: missing matter. Not dark matter this time, but ordinary, everyday atoms, the stuff that makes up stars, planets, and even our own bodies. According to the most precise cosmic calculations, the cluster should contain about 5 times more of this baryonic matter than we've actually detected. It's like weighing a suitcase, knowing exactly what you packed, then opening it to find most of your clothes have vanished without a trace. So where is it all hiding? The first place astronomers looked was the scorching plasma between galaxies. The Coma Cluster's intracluster medium glows with X-rays, betraying the presence of superheated gas enough to account for a significant chunk of the missing matter. But here's the catch: even that vast ocean of plasma only adds up to about a third of what's expected. The rest nowhere to be found. Some theorize the answer lies in cosmic filaments, thread-like structures of warm gas weaving between galaxies, too diffuse to emit detectable X-rays but collectively massive enough to tip the scales. Imagine mist so fine it's invisible until you're drenched. These filaments might be the universe's version of that, soaking the cluster in unseen material. Then there's the dark horse candidate: rogue planets and failed stars. The space between galaxies could be littered with billions of cold, free-floating worlds, Jupiter-sized objects ejected from their solar systems during the cluster's violent history. Or perhaps it's swarms of brown dwarfs, stellar misfits too heavy to be planets but too light to ignite fusion. These dark, drifting objects would be nearly impossible to spot at such distances, yet their combined mass might solve the puzzle. But the most intriguing possibility, the missing matter might not be missing at all, just transformed. Under the extreme conditions of the cluster's core, protons and neutrons could be breaking down into exotic particles we've yet to discover. Or perhaps the baryons are there, just locked away in primordial black holes, relics of the early universe hiding in plain sight. The implications are staggering. If ordinary matter can vanish or masquerade as something else, it forces us to rethink not just galaxy clusters, but the fundamental nature of matter itself. Every telescope pointed at the Coma Cluster's voids brings us closer to an answer, hunting for whispers of this cosmic hide and seek. And when we find it, we won't just solve a cluster's mystery, we'll rewrite the inventory of the universe. At the heart of the Coma Cluster looms a cosmic titan, NGC 4889, one of the largest galaxies ever discovered. This elliptical behemoth stretches over 2 million light-years from edge to edge, so vast that if placed in the Milky Way's neighborhood, it would swallow Andromeda with room to spare. But size isn't what makes this galaxy truly bizarre. It's what's missing the telltale signs of cosmic violence we'd expect from something so colossal. Start with its supermassive black hole. Every galaxy this size should harbor an active, ravenous monster at its core, devouring matter and spewing energy across the spectrum. Yet NGC 4889's black hole is eerily quiet, like a sleeping dragon curled around an empty hoard. Astronomers estimate this gravitational Goliath weighs in at a staggering 20 billion suns, one of the most massive ever measured, but it hasn't feasted in eons. The dust and gas that should be spiraling into its maw have somehow been cut off, leaving the beast dormant. Some suspect past outbursts blasted away its fuel supply, while others think the cluster's extreme environment starved it, like a desert withering an oasis. Then there's the galaxy's star formation, or rather, the lack of it. Unlike spiral galaxies churning out new stars, NGC 4889 is a celestial retirement home, its population of ancient red stars silently fading. This isn't just normal aging, it's cosmic hibernation. The galaxy's last burst of star birth likely ended billions of years ago, and theories abound as to why. One clue lies in its surroundings. The Coma Cluster's intracluster gas is so hot it prevents cool hydrogen from settling back into the galaxy, effectively cutting off its star-making fuel. It's like a tree whose roots have been severed, unable to grow new leaves. But here's the twist: NGC 4889 wasn't always this quiet. Telltale shells of stars, subtle ripples in its structure hint at a violent past. These are the cosmic equivalent of tree rings, marking a history of galactic cannibalism. The galaxy likely grew to its enormous size by devouring smaller neighbors, their stars assimilated into its halo. Yet today, those mergers have ceased, leaving behind a paradox, a galaxy built by chaos, now frozen in stillness. What makes this giant so fascinating isn't just its present state, but what it reveals about galactic life cycles. If even the most massive galaxies can shut down, it suggests a universal rule that all cosmic structures, no matter how grand, eventually exhaust their fuel and go dormant. NGC 4889 stands as a warning from the future, showing us what awaits when the fires of creation finally burn out. Nestled within the chaos of the Coma Cluster, NGC 4921 stands out as a cosmic contradiction, a spiral galaxy so faint it's barely there. Dubbed the Ghost Galaxy, its wispy arms stretch across space almost transparently, with stars spread so thinly you could peer straight through them. This shouldn't happen. Spiral galaxies in dense clusters like Coma are supposed to be ripped apart by gravitational forces, their delicate structures shredded into featureless blobs. Yet here's NGC 4921, clinging to its spiral elegance against all odds, like a dancer maintaining grace in a hurricane. What makes this galaxy so baffling isn't just its persistence, it's the way it's fading. Unlike typical spirals brimming with star-forming gas, NGC 4921 is running on empty. observations reveal its hydrogen reserves, the fuel for new stars, have been almost completely stripped away, leaving behind a skeletal framework of aging stars. The leading theory points to the cluster's brutal environment. As the galaxy plows through the Coma Cluster's superheated gas at millions of kilometers per hour, the resulting ram pressure acts like a cosmic squeegee, scrubbing away its gas in a process astronomers call starvation. Normally, this would spell doom for a spiral structure. Without fresh stars to reinforce its arms, the galaxy should dissolve into a shapeless haze. But NGC 4921 isn't following the script. Its spiral arms, though faint, remain astonishingly intact. This has led to a startling realization. The galaxy might be held together by an unusually massive dark matter halo. Dark matter's gravitational glue could be providing just enough stability to keep the structure from unraveling, even as its visible matter fades. It's like a building with invisible steel beams. Take away the bricks and the frame still stands. The plot thickens when you look closer. Embedded within the galaxy's ghostly arms are tiny, stubborn pockets of star formation, fleeting sparks of blue in an otherwise red-dominated landscape. These suggest that while the cluster's environment has starved NGC 4921 of most of its gas, traces linger in shielded nooks, fighting to ignite new stars against impossible odds. Some researchers think magnetic fields might be corralling these last gas reserves, protecting them from being stripped away. Others propose the galaxy is a recent arrival to the cluster's core, giving it just enough time to hang onto its identity before the environment erases it completely. The most haunting possibility, we might be witnessing NGC 4921 in its final act. If so, it's offering astronomers a rare front-row seat to a cosmic metamorphosis, showing how the universe transforms vibrant spirals into the faint, featureless ellipticals that dominate clusters like Coma. But until the last of its gas is gone and its spiral arms finally fade, this ghostly galaxy remains a silent rebel, challenging our assumptions about how galaxies live, die, and endure in the universe's most unforgiving neighborhoods. Deep within the Coma Cluster's scorching atmosphere, astronomers have stumbled upon something utterly bizarre: vast, empty bubbles stretching hundreds of thousands of light years across, floating like cosmic soap suds in a sea of superheated gas. These aren't just random voids, they're X-ray cavities, regions where the cluster's plasma is significantly cooler and less dense than its surroundings. And their existence points to a cataclysmic past, one where the cluster's central galaxy's unleashed energy bursts powerful enough to punch holes in the fabric of space itself. The leading explanation for these cavities reads like a cosmic detective story. At the heart of the Coma Cluster, supermassive black holes in galaxies like NGC 4889 likely went through periods of violent activity, devouring matter and spewing out jets of energy at near light speeds. These jets, packed with charged particles and magnetic fields, would have plowed through the surrounding gas, carving out colossal bubbles in their wake. Imagine blowing into a bowl of soup with such force that the steam parts and leaves behind empty pockets. That's essentially what happened here, but on a scale so immense it defies comprehension. What's truly puzzling, though, is why these cavities haven't collapsed. In most environments, such voids would be crushed by external pressure within millions of years, like a balloon popping under the weight of the ocean. Yet in the Coma Cluster, these bubbles have persisted for hundreds of millions, possibly even billions of years. The secret might lie in their composition. Some theories suggest the cavities are filled with ultra-hot, magnetized plasma from the original jets, creating a buoyant force that counteracts the pressure from the surrounding gas. Others propose that the bubbles are lined with shock waves, frozen in place like cosmic sound barriers, preventing the walls from caving in. But there's a twist: the cavities aren't just passive relics. They might still be shaping the cluster's evolution today. By displacing vast amounts of hot gas, these bubbles could be regulating the Coma Cluster's temperature, preventing the gas from cooling too quickly and stifling star formation across thousands of galaxies. It's a cosmic feedback loop. Black hole outbursts create cavities, which in turn control the environment that fuels future outbursts. This delicate balance suggests that even in the most violent corners of the universe, there's an underlying order, a hidden rhythm to the chaos. The implications stretch far beyond the Coma Cluster. If these cavities can endure for cosmic epochs, they could be hiding in plain sight throughout the universe, unnoticed until now simply because we didn't know to look for them. And if their longevity is tied to exotic physics like unknown particle interactions or dark matter's influence, they might hold clues to some of the universe's deepest mysteries. For now, these ghostly bubbles remain a testament to the titanic forces that shape galaxy clusters, reminding us that even in the emptiest corners of space, nothing is ever truly quiet. The space between galaxies in the Coma Cluster isn't just empty, it's a seething cauldron of superheated gas, reaching temperatures upwards of 80 million degrees Celsius. That's hotter than the core of the Sun, and it's posing a serious problem for astrophysicists. According to every known model, the intracluster medium, the plasma filling this cosmic void, shouldn't be this scorching. The numbers refuse to add up, leaving scientists scrambling to figure out what's pumping so much energy into this invisible ocean. One of the prime suspects is the sheer violence of the cluster itself. The Coma Cluster is a gravitational thunderdome where galaxies collide at speeds approaching thousands of kilometers per second. Every time two galaxies slam together, they generate shock waves that ripple through the surrounding gas, heating it like a hammer striking an anvil. These shocks don't just fade away, they pile up layer upon layer, cranking the temperature higher and higher over billions of years. It's the cosmic equivalent of a pressure cooker left on too long. Eventually, the steam has nowhere to go but up. But shocks alone can't explain the extreme temperatures. Something else is at work here, possibly tied to the cluster's turbulent magnetic fields. Threaded through the intracluster medium are invisible lines of magnetic force, twisted and braided by the chaotic motions of galaxies. When these fields snap and reconnect, a process called magnetic reconnection, they release staggering amounts of energy, like a rubber band suddenly breaking. Some researchers think this could be the missing piece, acting as a hidden furnace that keeps the gas unnaturally hot. Then there's the dark matter factor. The Coma Cluster's immense halo of invisible mass might be stirring the gas in ways we can't directly observe. As dark matter particles interact gravitationally, they could generate subtle currents in the plasma, transferring energy without leaving a visible trace. It's like an unseen hand stirring a pot, ensuring the heat spreads evenly. The real mystery, though, is how this overheated environment affects the cluster's future. Hot gas resists collapsing to form new stars, effectively sterilizing entire galaxies. If the intracluster medium stays this feverish, it could mean the Coma Cluster is destined to become a cosmic graveyard, a place where star formation flickers out, leaving behind only cooling embers. Yet, even in this extreme state, the system finds balance. Some galaxies manage to shield pockets of cooler gas, while others might be drawing fuel from hidden reservoirs, fighting back against the heat. What makes this puzzle so compelling isn't just the science, it's the stakes. If we can unravel why the Coma Cluster's gas defies expectations, it could rewrite our understanding of how all galaxy clusters evolve. The answers might lie in physics we've yet to discover, hidden in the interplay between visible chaos and invisible forces. And that's what keeps astronomers staring into this cosmic forge, searching for clues in the glow of superheated plasma. Stretching across the Coma Cluster like jewels on an invisible thread, a peculiar formation of galaxies has astronomers utterly captivated. This so-called string of pearls isn't just eye-catching, it's a potential window into the hidden skeleton of the universe. 7 galaxies line up with uncanny precision, each separated by roughly similar distances, as if strung together by cosmic design. Such perfect alignment shouldn't happen by accident. Given the chaos of galaxy clusters where gravitational tugs send objects careening in all directions, the odds of a naturally occurring straight-line arrangement are astronomically low. This has led to a compelling theory. The string of pearls might be tracing a dark matter filament, one of the universe's vast, invisible highways. According to cosmological models, dark matter weaves a complex web throughout the cosmos, with dense clusters like Coma forming at the intersections of these threads. Galaxies sliding along these filaments would naturally fall into linear formations like beads on a string, but there's a twist. Not all researchers are convinced the alignment is meaningful. Some argue it could simply be a fluke of perspective, a trick of the angle at which we're viewing the cluster. From our vantage point, galaxies scattered randomly in three-dimensional space might appear aligned when they're actually at very different depths. It's the cosmic equivalent of seeing distant streetlights line up perfectly from a car window, even though they're staggered along a winding road. The debate hinges on precise distance measurements. If follow-up observations confirm the galaxies are truly equidistant from Earth, the filament theory gains ground. Already, subtle clues support this idea. The galaxies in the string of pearls share unusual kinematic properties, moving in similar directions at similar speeds. Such coherence strongly suggests an underlying structure is guiding them. What makes this formation so tantalizing is its potential to reveal dark matter's influence in real time. If these galaxies are indeed sliding along a filament, their movements could help us map the invisible scaffolding of the cosmos. But if it's just a cosmic illusion, the string of pearls becomes a reminder of how easily even the sharpest eyes can be fooled by the universe's grand scale. Either way, this delicate alignment poses a beautiful challenge, forcing us to question whether we're seeing a hidden order or simply a fleeting pattern in the chaos. Beneath the visible chaos of the Coma Cluster lies an invisible force shaping its destiny: magnetic fields. These colossal lines of force, stretching millions of light-years, are the universe's silent puppeteers, bending cosmic rays, twisting plasma, and leaving fingerprints on everything from star formation to galaxy collisions. Yet despite their influence, we can't even see them directly. Instead, their presence betrays itself through subtle clues like the way they polarize light from distant quasars or sculpt the paths of high-energy particles screaming through space. One of the most startling discoveries about these fields is their sheer strength. In some regions, they're up to 1,000,000 times more powerful than Earth's magnetic field, strong enough to deflect charged particles at nearly the speed of light. Where did such monstrous forces come from? The leading theory points to turbulence on an unimaginable scale. As galaxies churn through the cluster's superheated gas, their motions generate electric currents, which in turn spawn magnetic fields. Over billions of years, these fields amplify like a dynamo, spinning faster and faster until it becomes a cosmic powerhouse. But there's a catch. Simulations suggest this process shouldn't produce fields this strong. Something else, perhaps primordial magnetism left over from the Big Bang or energy injected by dark matter, might be supercharging them beyond what ordinary physics allows. Then there's their role as cosmic sculptors. Magnetic fields don't just exist passively, they actively mold the cluster's evolution. Take star formation. In most galaxies, dense clouds of gas collapse under gravity to birth new stars. But in the Coma Cluster, magnetic fields can prop up these clouds, preventing their collapse like an invisible scaffold. The result? Entire galaxies starved of stellar newborns, their futures frozen by forces we can barely detect. Elsewhere, these fields funnel high-energy particles into beams, creating natural accelerators that launch cosmic rays across intergalactic space. Some of these rays hit energies so extreme they rival the Large Hadron Collider, but without a single human-built magnet in sight. But the real enigma is how these fields maintain their structure. In most environments, magnetic fields should decay, their energy dissipating like smoke in the wind. Yet in the Coma Cluster, they persist for billions of years, defying entropy. One tantalizing possibility involves dark matter. If certain dark matter particles interact weakly with magnetic fields, they could act as a cosmic stabilizer, subtly reinforcing the field structure like an invisible hand steadying a wobbling top. Another theory suggests the cluster's turbulent plasma constantly regenerates the fields, creating a self-sustaining loop where energy is recycled faster than it can fade. What makes these invisible forces so critical isn't just their mystery, it's their universality. If magnetic fields this strong and persistent exist in the Coma Cluster, they likely weave through the entire cosmos, shaping galaxies everywhere in ways we're only beginning to grasp. And until we unlock their secrets, we're missing a fundamental piece of the puzzle, one that might explain everything from the distribution of cosmic rays to the very fate of galaxies themselves. For now, these hidden filaments of force remain one of the universe's great silent players, their full story written in a language we're still learning to read. Imagine a supermassive black hole, an object so heavy it bends the fabric of space around it, suddenly hurled into the void like a cosmic outcast. That's exactly what astronomers think they've found in the Coma Cluster, a rogue black hole untethered from any galaxy, drifting through intergalactic space with nothing but darkness in its wake. This isn't just unusual, it's practically unheard of. Black holes this massive, weighing in at billions of times the Sun's mass, should be anchored at the centers of galaxies. So how did this one break free? The answer might lie in the cluster's chaotic gravitational dance. When galaxies collide, their central black holes inevitably spiral toward each other, locked in a deadly orbital embrace. Normally, they merge, a process that sends ripples through space-time we call gravitational waves. But sometimes, if a third galaxy joins the fray, the intricate gravitational ballet can fling one of the black holes away at staggering speeds. Picture a slingshot effect on a cosmic scale. As the black holes swing past each other, their mutual pull accelerates one to escape velocity, ejecting it into the abyss. There's another, even more violent possibility. If the black holes approach each other at just the right angle, the gravitational waves they emit might not be symmetrical. The resulting kick, like a rocket engine firing unevenly, could punt one of them clean out of its galaxy. Simulations suggest these recoils can reach speeds over 5,000 kilometers per second, fast enough to overcome even a massive galaxy's gravitational grip. Now here's where it gets truly bizarre. If this black hole was ejected, it might not be traveling alone. Stars that once orbited it could have been dragged along, clinging to its gravitational influence like moths to a flame. That means somewhere out there, a ghostly entourage of stars could be following this dark wanderer, invisible except for the faint glow of their stolen light. Some researchers even speculate that gas ripped from its original galaxy might still be falling into the black hole, powering a dim, wandering quasar, a lighthouse adrift in the cosmic ocean. The implications are staggering. If supermassive black holes can be ejected so easily, it challenges our understanding of how galaxies form and evolve. These monsters are supposed to regulate star formation, shape galactic cores, and anchor entire systems. A universe where they can go rogue is one where the rules of cosmic architecture are far more flexible than we ever imagined. And if this black hole is still active, it could be seeding the intergalactic medium with energy and heavy elements, quietly influencing the growth of galaxies it will never call home. Right now, the runaway black hole remains a candidate, an intriguing shadow in the data that demands further scrutiny. But if confirmed, it would be one of the most striking examples of the Coma Cluster's gravitational ferocity, proving that even the universe's most massive objects aren't immune to being thrown off course. And somewhere in that chaos, there's a lesson. In a cluster this wild, no celestial object, no matter how powerful, is truly safe from being cast adrift. The idea of a galaxy made almost entirely of dark matter sounds like science fiction until you look at the Coma Cluster. Here, astronomers have found galaxies so faint they barely register on telescopes, yet their gravitational pull suggests something massive is lurking inside them. These so-called dark galaxies challenge everything we thought we knew about galactic structure, and the Coma Cluster might be the perfect place to find them. Take Dragonfly 44, for example. This ghostly galaxy emits just 1% of the light we'd expect from its mass. Most of that mass comes not from stars or gas, but from something invisible, dark matter. The numbers are staggering. For every bit of visible matter, there's roughly 100 times more dark matter holding the galaxy together. It's like discovering a skyscraper where only the windows are visible, while the steel frame remains completely hidden. But how do these shadowy structures form? One theory suggests they're cosmic leftovers, galaxies that failed to light up. In the early universe, clouds of gas collapsed under gravity to form stars, but in some cases the gas might have been too diffuse or too turbulent to ignite star formation efficiently. Over time, these dark matter halos could have gathered stray stars from collisions or tidal forces, creating the faint smudges we see today. The Coma Cluster's violent environment would only amplify this process, with gravitational interactions stripping away what little visible matter these galaxies had while leaving their dark matter intact. Not everyone's convinced, though. Skeptics argue that some of these dark galaxies might just be artifacts of measurement errors or unusual star distributions. Without more direct evidence, it's hard to say for sure. That's where new tools like the James Webb Space Telescope come in. By peering deeper into these enigmatic objects, we might finally catch glimpses of the sparse stars or faint gas clouds that could confirm their true nature. What makes the dark galaxy hypothesis so compelling isn't just the mystery, it's the implications. If these structures are real, they could be the missing link in our understanding of dark matter's role in galaxy formation. They might even help explain why some theories overpredict the number of small galaxies we see in the universe. Perhaps the missing galaxies aren't missing at all, they're just too dark to find. The Coma Cluster, with its extreme density and turbulent history, provides the perfect laboratory to test these ideas. Every faint galaxy we uncover here forces us to rethink the balance between the seen and the unseen in the cosmos. And if dark galaxies do dominate the cluster's unseen population, it could mean we've only been seeing half the universe's story all along. The Coma Cluster holds another cosmic surprise in the way its galaxies manage their glittering entourages, their globular clusters. These dense, spherical collections of ancient stars typically orbit galaxies like loyal attendants, but here the numbers are all wrong. Some galaxies sport far more globular clusters than they should, while others have shockingly few. It's as if the universe threw a handful of confetti into the cluster, only for it to land in bafflingly uneven patches. Take the giant elliptical galaxy and you see 4874, which boasts an entourage of thousands of globular clusters, a count that dwarfs the Milky Way's modest collection of about 150. Normally, a galaxy's wealth of globulars reflects its past mergers, as each collision deposits a fresh batch into its halo. But NGC 4874's hoard is so excessive it suggests a history of galactic feasting on an almost gluttonous scale. Then there are galaxies like IC 4051, which barely cling to a handful of clusters as if they've been robbed of their stellar jewelry. This bizarre imbalance points to the Coma Cluster's violent past. When galaxies collide, their globular clusters don't always follow neatly. Some get ripped away by tidal forces, scattered like marbles dropped onto a trampoline. Others might be captured by larger galaxies, stolen in gravitational heists that leave their original homes barren. The cluster's frenzied environment acts like a cosmic casino. Some galaxies hit the jackpot, while others walk away nearly empty-handed. But there's a twist. The distribution isn't entirely random. Many of the cluster's globular-rich galaxies sit near its core, where gravitational interactions are fiercest. This hints at a ruthless sorting mechanism where only the strongest galaxies keep their clusters while weaker ones are stripped bare. Even stranger, some globulars seem to float freely between galaxies, unattached to any galactic master, ghosts of mergers past drifting in the void. What makes this puzzle so tantalizing is what these orphaned clusters reveal about the cluster's formation. Their chemical composition acts as a time capsule, preserving clues about the conditions of the early universe. Some might even predate the galaxies they now orbit, making them among the oldest structures in existence. If we could trace their paths backward, we might unravel the Coma Cluster's entire merger history, a chronicle written not in stars but in the silent wanderers that move between them. For now, the uneven distribution of these ancient stellar swarms remains one of the cluster's quietest yet most telling mysteries. Whether they're survivors of cosmic chaos or pawns in a galactic game of theft, their story is far from over. And with every new observation, we get closer to understanding how the universe's most violent neighborhoods shape even the smallest of their inhabitants. Stretching across the Coma Cluster like an invisible veil of energy, a persistent gamma-ray glow has astronomers both fascinated and deeply puzzled. Unlike the brilliant bursts we associate with supernova or colliding neutron stars, this emission is diffuse, uniform, and most bafflingly without any obvious source. It's as if the entire cluster is humming with some unseen power, radiating high-energy light that shouldn't exist under known astrophysical models. The glow is so intense that if our eyes could perceive gamma rays, the Coma Cluster would outshine the moon in our night sky. So where is all this energy coming from? The leading hypothesis takes us straight to the shadowy realm of dark matter. Certain theoretical particles, like WIMP weakly interacting massive particles, could be annihilating each other in the cluster's dense heart, converting their mass into pure energy in the form of gamma rays. It's a tantalizing idea, one that could finally give us a direct window into dark matter's nature. The Coma Cluster, with its immense gravitational grip and high concentration of invisible mass, would be the perfect place for such particle collisions to occur at scale. If this theory pans out, we might be witnessing the fingerprints of the universe's most elusive substance, but not everyone's convinced. Skeptics point to more conventional, though no less extreme astrophysical processes. The Coma Cluster's turbulent environment, where galaxies and gas collide at mind-bending speeds, could be accelerating cosmic rays to energies so high they produce gamma rays upon impact. Picture a celestial pinball machine where charged particles ricochet off magnetic fields and plasma shocks, gaining energy with each bounce until they erupt in flashes of radiation. This hadronic model has its own appeal, especially given the cluster's violent history of mergers and collisions. Then there's the wild card, primordial black holes. Some theorists speculate that countless tiny black holes, relics from the universe's infancy, might be peppered throughout the cluster. As these ancient objects evaporate via Hawking radiation, they could release gamma rays in their death throes, contributing to the mysterious glow. It's a long shot, but in a puzzle this complex, no possibility can be ruled out. What makes this gamma ray enigma so critical is what it reveals about the cluster's hidden dynamics. Whether the glow stems from annihilating dark matter, raging cosmic accelerators, or exotic black holes, it's a signpost pointing to forces operating beyond the limits of our current understanding. And until we crack the code, this silent, shimmering veil of energy remains one of the Coma Cluster's most electrifying mysteries, literally. Tucked away in the heart of the Coma Cluster, astronomers have uncovered a structure so perfect it seems sculpted by cosmic hands, a colossal ring of scorching gas stretching over 600,000 light-years across. This ring of fire isn't just visually striking, it's a thermal anomaly with temperatures soaring to nearly 70 million degrees Celsius. What makes it truly perplexing isn't just its heat, but its near-perfect symmetry, a shape so precise it defies the chaos of its surroundings. One explanation points to a cataclysmic collision, When two galaxies merge, the shockwaves can ripple through the surrounding gas like a stone dropped in a pond, compressing and heating the material into a circular wave. In the Coma Cluster's gravitational frenzy, such collisions are commonplace. The ring might be the aftermath of a particularly violent encounter, where the gas was forced outward in a near-perfect sphere before cooling into the fiery loop we see today. It's like a cosmic echo, freezing a moment of impact in time. But there's another, even more tantalizing possibility. The ring could be a cosmic sonic boom. As galaxies hurtle through the cluster's superheated plasma at thousands of kilometers per second, they create shock fronts in their wake like the bow waves of a ship sailing through interstellar seas. If one of these galaxies moved with just the right speed and angle, the resulting shock might have sculpted the gas into this unnatural symmetry. Supporting this theory, the ring's edges show telltale signs of compression, where gas has been squeezed and heated by passing pressure waves. Yet the puzzle deepens when you consider the ring's longevity. Structures like this should dissipate within a few 100 million years, smeared apart by the cluster's turbulent motions. The fact that it persists suggests something is continually reinforcing it, perhaps hidden magnetic fields channeling the gas, or dark matter's invisible gravity acting as a stabilizing force. What makes the Ring of Fire so captivating isn't just its origin. It's a living laboratory for extreme physics, a place where we can study how energy propagates through the universe's most hostile environments. And if it was forged by a collision, it offers a rare glimpse into the aftermath of cosmic violence, frozen in a loop of glowing plasma. For now, this perfect circle of fire remains one of the Coma Cluster's most elegant enigmas, a reminder that even in the universe's chaos, there's room for fleeting moments of order. One of the most counterintuitive mysteries in the Coma Cluster isn't about what's there, it's about what isn't. The superheated gas between galaxies, known as the intracluster medium, is strangely, almost unnervingly smooth. Given the cluster's reputation as a gravitational war zone, you'd expect this gas to be churned into violent whirlpools with temperatures and densities fluctuating wildly. Yet observations reveal a far calmer sea where the plasma flows with unexpected uniformity, like syrup poured onto a table rather than water tossed into a storm. This eerie smoothness shouldn't be possible, and it's forcing scientists to rethink how energy behaves in the universe's most extreme environments. Start with the basics. The intracluster medium is a broth of charged particles, heated to tens of millions of degrees by countless galactic collisions and shock waves. In such a chaotic system, turbulence should be inevitable. Imagine stirring cream into coffee, where eddies and swirls form naturally. But the Coma Cluster's gas lacks these expected fingerprints of turbulence, revealing a startling disconnect between theory and reality. Some researchers point to magnetic fields as the invisible hand smoothing things over. Threaded through the plasma, these fields might act like cosmic shock absorbers, dampening chaotic motions and organizing the gas into smoother flows. It's as if the universe wrapped the cluster in an invisible blanket, muffling its turbulence. There's another, more tantalizing possibility: dark matter's unseen influence. While dark matter doesn't interact with the gas directly, its gravitational pull could be subtly shaping the intracluster medium's behavior. Simulations suggest dark matter halos might stabilize the gas, preventing large-scale turbulence from taking hold. Think of it like a dancer guiding their partner. The dark matter's steady presence could be leading the gas into smoother movements, even amidst the chaos. But the plot thickens when you consider the cluster's history. The Coma Cluster didn't form peacefully. It grew through violent mergers, each collision injecting enough energy to stir the gas into a frenzy. So where did all that energy go? One theory suggests it's being siphoned off by cosmic rays, high-energy particles that steal energy from turbulence and carry it away. Another idea proposes that the gas is simply too hot for turbulence to persist, with particles moving so fast they erase small-scale irregularities before they can grow. The implications stretch far beyond the Coma Cluster. If we can't explain why the gas here is so smooth, our models of galaxy clusters everywhere might need revision. Turbulence plays a crucial role in how these systems evolve, influencing everything from star formation to the growth of supermassive black holes. A universe where turbulence mysteriously vanishes is one where we've missed a fundamental piece of physics. For now, the Coma Cluster's tranquil plasma remains a quiet enigma, a reminder that even in the cosmos's most chaotic corners, there are still pockets of order waiting to be understood. And until we crack this puzzle, we're left staring into the calm, wondering what invisible forces are at work beneath the surface. At the heart of the Coma Cluster looms NGC 4874, a galaxy so massive it bends the rules of cosmic construction. This behemoth weighs in at nearly a quadrillion times the mass of our Sun, making it one of the most overmassive galaxies ever discovered. But here's what's truly baffling. According to our best models of galaxy formation, something this colossal shouldn't exist. The reigning theory, called hierarchical merging, predicts galaxies grow gradually over time, absorbing smaller neighbors like cosmic snowballs rolling downhill. Yet NGC 4874's sheer bulk suggests it didn't just grow. It gorged, feasting on galaxies at a rate that defies expectations, the smoking gun. Its sprawling entourage of globular clusters, dense balls of ancient stars that orbit galaxies like satellites. Most galaxies have a few hundred at most, but NGC 4874 boasts thousands, each one a trophy from a past galactic merger. This excess isn't just a curiosity, it's a direct challenge to hierarchical models which struggle to explain how a single galaxy could hoard so many mergers without disrupting its structure. Imagine a spider sitting at the center of a web, patiently wrapping prey after prey, except in this case, the spider shouldn't have been able to catch that many flies without tearing its own web apart. But the plot thickens when you consider the galaxy's core. Nestled within it lies a supermassive black hole so ponderous it tips the scales at 20 billion solar masses, one of the heaviest ever measured. Hierarchical models predict black holes grow in lockstep with their host galaxies, yet NGC 4874's monster is disproportionately massive, as if it swallowed rivals far faster than the galaxy itself expanded. Some theorists speculate this black hole might be the key to the galaxy's unnatural growth. In rare cases, a black hole's gravitational influence can extend far beyond its immediate surroundings, funneling gas and even whole galaxies toward its host in a process called black hole boosting. It's like a cosmic vacuum cleaner, sucking in material at rates that bypass normal growth limits. Yet even that explanation leaves gaps. Observations reveal NGC 4874's outer halo is far smoother than merger-heavy histories would predict, lacking the telltale stellar streams and shells that usually mark galactic cannibalism. One radical idea suggests the galaxy didn't grow through countless small mergers, but through a handful of gargantuan ones. Picture two already massive galaxies colliding head-on, their stars and dark matter blending seamlessly into a single, even larger titan. Such dry mergers could explain the galaxy's polish, but they'd require a cosmic coincidence, a perfect alignment of pre-formed giants in the early universe. What makes NGC 4874 so pivotal isn't just its defiance of models. It's a living challenge to our understanding of how the universe builds its largest structures. If hierarchical merging can't account for this galaxy's extremes, we might need entirely new physics, or at least a radical rethink of how dark matter and baryonic matter interact during collisions. For now, this overmassive enigma looms over the Coma Cluster like a cosmic question mark, reminding us that even our best theories are just rough sketches of a far stranger reality. Buried within the radiostatic of the Coma Cluster lies something even more mysterious than the active galaxies we see today, the ghostly whispers of black holes that died billions of years ago. Astronomers call them fossil radio sources, vast structures of faint emission stretching hundreds of thousands of light years, their shapes frozen in time like ancient footprints in cosmic mud. These aren't just relics, they're crime-scene evidence pointing to violent outbursts from supermassive black holes that once raged at the hearts of galaxies but have since gone silent. The first clue to their origin comes from their bizarre shapes. Unlike the crisp, focused jets we see from active galactic nuclei today, these fossil sources are smeared and distorted, their once powerful radio lobes stretched and twisted by the cluster's turbulent motions. It's as if someone pressed pause on a black hole's eruption mid-explosion, then let the cluster's chaos slowly smear the aftermath across the sky. The most famous example, known as Coma C, spans nearly half the cluster's width, a fossil so colossal it defies easy explanation. But here's what really puzzles scientists. These structures shouldn't still be visible. Radio emissions from dead black holes are supposed to fade within 100 million years as their electrons lose energy. Yet some of the Coma Cluster's fossils persist for billions of years, outliving their creators by orders of magnitude. One theory suggests the cluster's magnetic fields are acting like cosmic refrigerators, preserving the radio-emitting particles by preventing them from dissipating. Imagine a bubble of energy so perfectly insulated that its light lingers long after the bulb has burned out. Another possibility is even more intriguing. These fossils might not be entirely dead after all. Some researchers propose that shock waves from passing galaxies or collisions with intracluster gas could be re-energizing the ancient particles, giving them a second wind. It's the cosmic equivalent of blowing on dying embers to revive a fire. If true, it would mean the Coma Cluster isn't just preserving these structures, it's actively resurrecting them, turning graveyards into laboratories. What makes these whispers from the past so valuable is what they reveal about the cluster's formative years. The size and distribution of fossil sources suggest the Coma Cluster was once a far more violent place, with supermassive black holes erupting in synchrony across the entire region. Some might have been triggered by the cluster's initial collapse, while others could mark the moments when major mergers injected fresh gas into starving galaxies, briefly reawakening their dormant monsters. Each fossil is a timestamp capturing a snapshot of when the cluster's black holes were last fed. Yet the biggest revelation might be what they tell us about dark matter. The way these radio ghosts are distributed aligns eerily well with maps of the cluster's invisible mass, hinting that dark matter's gravity could be shaping not just galaxies, but the remnants of their most violent eruptions. If we can decode the patterns in these ancient signals, we might finally glimpse the hidden architecture that's been guiding the cluster's evolution all along. For now, these fading echoes remain one of the Coma Cluster's most profound puzzles, a reminder that even in silence, the universe never stops speaking. The longer we listen, the more we realize that some voices from the past aren't gone. They're just waiting for us to understand what they've been trying to say. For decades, our models of galaxy formation have told a tidy story. Giant galaxies like those in the Coma Cluster should be surrounded by swarms of smaller satellite galaxies like moons orbiting a planet. The math seemed airtight. Dark matter's gravitational pull would naturally gather these cosmic attendants during a galaxy's growth. Yet when astronomers pointed their telescopes toward the Coma Cluster's titans, they found something startling. Where hundreds of satellites should have been, there were only voids. This isn't just a curiosity, it's a full-blown cosmic whodunit known as the missing satellites problem, and the Coma Cluster might hold the key to solving it. Take NGC 4889, the cluster's central behemoth. Based on simulations, a galaxy of its size should host at least 50 visible satellites. But so far, barely a dozen have been confirmed. The discrepancy isn't just a matter of overlooked dim objects. Modern surveys like the Sloan Digital Sky Survey have scoured the region with unprecedented sensitivity, ruling out the possibility that we're simply missing faint galaxies. The satellites aren't hiding, they're gone. So where did they vanish? One leading theory points to the cluster's ruthless environment. The Coma Cluster isn't just dense, it's a gravitational slaughterhouse where smaller galaxies face annihilation from multiple fronts. Tidal forces from massive neighbors can stretch and shred satellites into streams of stars, dispersing them so thoroughly they fade into the intracluster light. Then there's RAM pressure stripping, where the cluster's superheated plasma acts like a cosmic sandblaster, scouring away the gas that might otherwise form new stars in these satellites, rendering them too dim to detect. It's as if the cluster is erasing its own history, dissolving the evidence of its past mergers. But here's where things get even stranger. Some of these missing satellites might not be missing at all, or just transformed. Simulations suggest that dark matter subhalos, the invisible scaffolding that should host satellite galaxies, do exist in the expected numbers. The problem: many never manage to gather enough gas to ignite star formation, leaving them as dark galaxies, ghostly structures of pure dark matter, invisible to our telescopes. If true, it means the Coma Cluster could be teeming with these shadowy counterparts, their presence betrayed only by subtle gravitational tugs on the visible matter around them. Then there's the wild card: reionization. In the early universe, fierce ultraviolet radiation from the first stars might have sterilized small galaxies before they could grow, boiling away their gas and stunting their development. If the Coma Cluster's satellites were victims of this cosmic sterilization, they'd have entered the cluster already stunted, doomed to fade into obscurity. What makes this mystery so crucial isn't just the missing satellites themselves, it's what they reveal about dark matter's nature. If our models of galaxy formation are correct but the satellites are invisible, it suggests dark matter behaves differently than we thought on small scales. Alternative theories like warm dark matter or self-interacting particles could explain why fewer satellites formed or why they're fainter than expected. The Coma Cluster, with its extreme conditions, is the ultimate testing ground for these ideas. For now, the phantom satellites remain one of cosmology's most tantalizing loose threads. Their absence forces us to question not just how galaxies form, but whether we're even looking for the right clues in the darkness. And until we solve this puzzle, every giant galaxy in the universe stands accused of hiding something, whether by destruction, invisibility, or a cosmic rule we've yet to uncover. The Coma Cluster isn't just another speck in the cosmos, it's a cosmic hall of mirrors, reflecting back at us all the ways our understanding of the universe still falls short. From galaxies moving at impossible speeds to dark matter that vanishes without a trace, from ghostly radio whispers of long-dead black holes to superheated gas that defies the laws of turbulence, every discovery here feels like the universe is teasing us with half-answered riddles. Think about what we've uncovered: a rogue supermassive black hole hurled into the void, entire galaxies made nearly invisible by dark matter, and star-forming blue blobs where no stars should exist. Then there's the missing satellites that defy predictions, the ultra-diffuse galaxies clinging to spiral arms against all odds, and the gamma-ray glow with no clear source. Each phenomenon isn't just a curiosity, it's a crack in the foundation of modern astrophysics, hinting at forces and particles we've yet to discover, the most humbling part. These 25 mysteries are just the beginning. For every question the Coma Cluster answers, it poses 10 more. What looks like a celestial flaw in one theory might be the first clue to something revolutionary, like dark matter behaving differently under extreme conditions, or magnetic fields wielding influence we never imagined. Even the cluster's calmest features, like its inexplicably smooth plasma or eerily aligned strings of galaxies, whisper secrets about the universe's hidden machinery. That's the real magic of this place. The Coma Cluster doesn't just challenge our textbooks, it invites us to rewrite them. It proves that the universe is far stranger, more dynamic, and more inventive than we ever anticipated. And if a single cluster 320 million light-years away can append so much of what we thought we knew, imagine what else is out there waiting in the darkness. So here's your call to action. Don't just watch the mysteries unfold, join the hunt. Every time you look up at the night sky, remember that places like the Coma Cluster are out there, bending the rules and daring us to think bigger. Stay curious, stay skeptical, and never stop asking why. Because the universe's greatest discoveries don't start with answers, they start with someone willing to question everything.